Hey everyone, welcome back, and today let's solve Leetcode problem 2962 titled Count Subarrays where max element appears at least k times. So we're given an integer array nums and a positive integer k, and the problem statement is really just the exact same as the title, where we really just have to return the number of subarrays where the maximum element of nums appears at least k times in that subarray, i.e. the subarray has a frequency of k that's greater than, or rather, a frequency of the max element that's greater than or equal to k. Now, a subarray is a contiguous sequence of elements within an array, and let's go ahead and see the examples here. In the initial example 1, we have our input array nums to be the following and k to be 2, and in this case we have an output of 6 because there's a total of 6 different subarrays that have a frequency of at least 2 of the maximum element of the entire input array nums. So first of all, what is the maximum element in the entire input array nums? Well, that's really just going to be this 3. And so in other words, we're really just trying to find the number of subarrays that have a frequency of 2 or greater of 3 in them, right? And in this case, the 6 subarrays that would work would be 1, 3, 2, 3. That has a frequency of 2 of 3. That works. 1, 3, 2, 3, 3 works. It still have a frequency of 2 or greater of the max element 3 in this subarray. 3, 2, 3 also works. We see 3, 2, 3, 3 also works. Excuse me. And we see 2, 3, 3 also works. And we see that the 2 adjacent 3s also work as well, giving us a total of 6. In example 2, we have our input array nums to be 1, 4, 2, 1. Our max element is 4, and k is 3. We only have 1, 4 in the entire input array nums, and so no subarray of the entire input array nums is going to have at least or greater than 3 4s in it, because we only have 1, 4 in the whole array. And so we have an output of 0 because there's 0 kind of valid subarrays, or subarrays that have that max element at least k times property. So for the constraints here, we see that the length of the input array nums and any value of the input array nums are going to be between 10 to the 5th and 6th power respectively, and our k value is going to be between 1 and 10 to the 5th power, which brings us to the main observations that we really need to make to solve this problem in the most efficient way, the most efficient solution and way possible. And what is that important kind of key takeaway or observation to make? Well, that we know we're always looking for subarrays where the maximum element of the whole array appears at least k times. And obviously, all we have to do is first pre-compute that value and use the kind of single iteration while loop or validating approach to solution structure. It's a very common solution structure to solve problems like this, or problems like find the longest subarray with this property. A good example that I can think of off the top of my head is, I believe, Leetcode problem 209, which is titled minimum subarray sum or something like that. It has a very similar structure to this solution, where effectively we're iterating through the input array only once, and we have a validating while loop, nested while loop within that for loop, while our subarray is non-valid, or while it's valid based on the problem context, right? And it's a very similar, a very common kind of variation of the sliding window technique, where basically once we actually pre-compute or first find the maximum value or our target value in the array, we then use a sliding window approach to actually count the number of subarrays that satisfy that condition, or has at least k copies of that maximum number, and we kind of just use 2 pointers left and right to help do that. Right, so let's go ahead and get into the code here. Let me just full screen the editor here. The first thing that we're going to do before we actually start iterating through the input is we want to first actually initialize all of our kind of target variables and pointers, if you will, and our output result values. And so the first thing that we're going to do is, very straightforwardly, we're going to pre-compute or find that maximum value in the entire array, kind of our target value that we want a frequency of at least k in all of the valid subarrays. So I'm going to call it max val, and very, very straightforwardly, it's going to be the maximum value of our input array nums, or whatever that may be. That's what, we want our subarrays to have a frequency of at least k of. We only care about this single maximum value, right? Because we determine the frequency of this in our subarrays to determine if they're valid or not. Now let's actually initialize our result or answer to be 0. This is really our output, right? That's why I call it answer. It's going to actually keep track and store the total number of valid subarrays that we find in the input array nums as we iterate over it. And now let's actually initialize a count. this is going to help be part of that kind of solution structure that I'm going to go over in a few minutes here. Well, basically, it's going to actually keep track of how many times we've seen that maximum value appear inside the current window that we're currently sliding and shifting across our input array nums, right? And finally, let's actually initialize our left pointer. That's going to be, of course, starting at 0, and we're actually going to use our right pointer to just be our iterator that iterates through the entire input array nums, and we're going to do that like so. So for every right value or right index in the range of the length of our input array nums, a very standard single iteration approach with the right pointer being our iterator itself. This is the right side or index of our sliding window that we actually expand at each step, right? Of course, right is going to move from 0 till the end of the array, and left is just going to be instantiated at 0. Right? Now, inside this loop, we're always going to first check if the current value is our maximum value, because it is. We know we've seen it one more time. The frequency of it in the current window is increased by 1 because we're not including it in our window, as we've seen it one more time in this current iteration. And the way we can check that is very straightforwardly. If nums at the current index or value right, if it equals that max value, that target value, if you will, we want to increment the count by 1, because the count is nothing but kind of the frequency of max val in our current window. And so we're going to increment the count by 1, indicating that we've seen the max value one more time at this current index or iteration right? Again, it's going to keep track of how many max elements we have currently inside our window that we're always going to be shifting in this while loop that we'll see right here. Now, what is that while loop going to be like? Well, while our count is valid, meaning while our window still satisfies the condition, it's still valid. How do we know that? Well, that means the count is still greater than or equal to k. Because that knows count is nothing again but the frequency of max val in our current window. And so while that frequency or while that count is still at least k, we know we still have a valid subarray. We know as long as the current window has at least k copies of the maximum number, we're going to enter this while loop to actually update our answer and shift the window to the left, right? Using, again, that left pointer. So how are we actually going to get our total number of valid subarrays in this current window that we can actually form while the count is still greater than k, meaning while our subarrays are still valid? Well, we can increment to our answer the length of nums minus whatever our right index is at right now. This is a little unique to this problem, at least in this context or in this sense, where this, oh, sorry. Never mind, I thought I forgot the parentheses. Where basically this, or whatever our right index is, this is going to help us get every single subarray that starts at left and ends anywhere from right to the end of the array. Because at the end of the day, while any subarray that ends at right, while it's valid, any subarray that starts at left and ends from anywhere farther right from right, it's still going to be valid. And to kind of put that into context here, assume we have 1, 3, 2, 3. Right now, right is at index 3, right? So we know 1, 3, 2, 3 already works. It's already valid because count is already greater than or equal to 2. Any values that we add to the right of this array and add to our current window, they're obviously just going to make our window either more valid or not make it harmful, right? Because adding values are never harmful to our window. Only subtracting values are if they are actually that max value. So any subarray that ends, or rather starts from this index and ends from any index after right, we know it has to be valid because any window that starts from left and ends at this right is valid itself. And so if we add values that end at the end or right more of the list, they're still going to be valid because adding elements to our window never hurts them, only removing them does. And so again, every subarray that starts at left and ends anywhere from right to the end of the array would still be considered valid. And so we're going to add the length of nums completely minus whatever our right is to get the number of subarrays that actually start at left and end anywhere from right, the number of elements, if you will, from right index till the end of the array, right? And we're going to add that as the number of total subarrays from this current window to our answer accordingly. Now, this is where we actually shift our window. To actually shrink the window, we first have to check, well, we're first going to, of course, increment our left pointer by 1, indicating that we're moving the left pointer by 1 and removing the leftmost element from our current window. And to do that, first, what if our leftmost element that we're currently removing, what if it's the max element? So if nums at left is actually equal to max value, we know that we're about to remove a max value. We're about to remove a maximum value element, and so we have to decrease the count by 1 and then actually remove it. And the way we remove it is doing nothing but incrementing our left by 1, indicating that we're just moving left forward by 1 to shrink the window 1 less, and continue checking while, again, our count is still greater than or equal to k. And effectively, once this goes for every single possible valid right index ending of every single possible array while it's still valid, meaning while count is still greater than or equal to k in the entire input array nums, once the for loop is fully done executing, once it fully terminates, we're going to return our answer because it's going to store the number of total valid subarrays that we found across the entire input array nums, and added and incremented to our answer accordingly in this while loop. So unless I made any syntax errors here, there should be accepted and there should be a valid solution. Let's go ahead and double check that. And as you can see, this really is just about as efficient as you can get it to be. So on a high level, what are we really doing here? A very standard while loop approach here. Well, we first actually pre-compute or find the maximum value in the array, and then we actually use our sliding window to actually iterate over the entire array, where every single time we find a window with at least k maximum values, we have to count all the possible subarrays that start from left and end at any index after right, because they would still be valid, as adding elements to a window don't make it any worse. And we have, of course, have to, while doing that, keep moving left forward to maintain that count condition while it's still valid. And by counting all these multiple different subarrays in one shot, we actually make the solution a lot more efficient than just having an n squared brute force find all valid subarrays, because this is actually decreased to big O of n for the linear complexity, which brings us to the runtime complexity, right? I just went over it. It's big O of n. It's a linear solution. Why? Because this really still is just a single pass iteration solution, a single for loop solution, where we scan each element once with the right pointer, and the left pointer, we know it's never going to move backward. It's only going to be incremented, meaning it's only going to move forward, and so the overall time is linear in the size of the array, or big O of n. And for the memory or space complexity, believe it or not, it's actually linear. It's actually constant, sorry. It's actually big O of 1. Why? Because we're not actually using any auxiliary memory or any extra data structures. We're only using a few extra integer variables like, max val, ands, count, left, and right. But these aren't actually any extra data structures, or they don't take up auxiliary memory. They don't scale linearly with the input. They're actually constant, meaning they're big O of 1, and so it doesn't depend on the size of our input array nums. Right, so if you guys enjoyed this solution and learned something new, please consider liking this video and subscribing to my channel. And without further ado, I will see you guys in the next video. Bye-bye.